Alright, we're on the last lesson of chapter 11. It's 11.9, solving radical equations. You'll be able to solve equations that contain radicals. A radical equation is an equation that has a variable in the radicand. In other words, if you have a square root, there's an x or a variable underneath it in the radicand. Okay, so here's an x, here's an x, here's an x, and they're inside. They're not outside, they're inside. So, what is the inverse operation of taking a square root? So if I do a square root, how do I get rid of it? And guess what? The answer is you square it. If you square a square root, they will cancel each other. I can do a quick example. The square root of 2, if I square that, I get this. Square root of 2 multiplied to the square root of 2. 2 times 2 is 4. Now I have the square root of 4. And what is the square root of 4? It's 2. So I could have just gone like this, and my answer would have been right in front of me. So, when an equation contains a variable with a square root, square both sides of the equation to solve it. And that's what I'm going to do. I'm going to square this and square this. This 2 will cross off the square root symbol. It cancels. So the x is out of jail. Okay? So we have x equals, now I have to say 5 squared is 25. Here, the square root is by itself, so I'm going to square both sides to keep it balanced. This square will cancel the square root. I end up with 100 on this side. And on the right side, the 2x is out of jail. It's free because the square and the square root cancel each other. Well, now all I have to do is railroad tracks, divide both sides by 2, and I get 50 equals x. Done. Okay, next one. Square root is by itself. I'm going to square both sides. This cancels. I have x equals 6 squared is 36. I'm all done. One more to go. How do I get rid of a square root? I square. So I put a square here and a square here. This cancels. So I have 81, 9 times 9, equals 27x. How do I get rid of a times 27? Divide both sides by 27. And let's reduce that. It actually equals 3 over 1. When I divide 81 by 27, I get 3. Perfect. Alright, some square root equations do not have the square roots isolated. So to solve these, you may have to isolate the square root before you square both sides. And this is important. You always have to have the square root by itself before you go and square. Otherwise, you end up with a mess. So, after you do that, then square root both sides. Here's our example. I need to move this 4 to the other side. So I'm going to add 4 to both sides. And I get 9 equals the square root of x. Now, what I can do is square both sides, because this square root will get canceled, and now I have x equals 9 times 9 is 81. That's my answer, and it works. A couple more examples. Alright, I see square root of x minus 2 equals 1. I need to get rid of this 2 so the square root can be by itself. So I'm going to add 2 to both sides, and I get 3 equals the square root of x. Okay. How do I get rid of a square root? I square both sides. These cancel so that x is free. And I end up with 3 squared is 9. We have kind of a bigger one here, but we can handle it. All of this is underneath the square root. That's good. 6 has to go. So I'm going to minus 6 from both sides, and I get 4. Next, I have the square root of 5x plus 1 equals 4. How do I get rid of a square root? I'm going to square this and square this. But realize all that does is cross this off so that the 5x plus 1, the radicand, is now outside. 4 squared is 16. Let's solve this. How do I get rid of a plus 1? I minus 1, and I get 15 equals 5x. All I have to do now is divide both sides by 5. I get x equals 3. All right, we have a couple more involving multiplication. So the radical is not by itself. There's a 4 multiplying it. So I need to divide both sides by 4 before I square anything. So 4 divided by 4 is 1. So I have the square root of x equals 8. 32 divided by 4. Now I can square both sides. This will cancel. And x is free. X equals 8 times 8. Fell on the floor. Pick it up. 64. Okay, let's do this one. I need to divide by 2 to get the radical by itself. When I do that, I get square root of x by itself, and I get 11. Next, how do I get rid of a square root? I square. This cancels this. I get x equals 11 times 11 is 121. That's my answer. All right, here are the practice problems. And do these. Bring any questions you have to class next time we meet. Take care.